Afternoon, everybody, and hello in these really strange times. So I'm John Roberts, and I'm a principal engineer at the Environmental Protection Group, or EPG, as we're more commonly known. I've been modelling and designing blue roof systems now for over 5 years, and I also get involved in a lot of at-grade SUDs. And I've got a long track record with working with landscape architects to involve SUDs from the outset of any project. So on a personal level, though, I am very keen on pursuing local authority SUDS retrofits, and I've managed to complete a number of those across the UK and further afield. So I'm based in not so sunny Cornwall, where I work from home, but our main offices are located in Warrington. So we're frequently involved in projects around Manchester. EPG have completed a lot of work in Manchester recently, and as Nicholas has already discussed today, we were involved in Angel Gardens in the modelling aspects. So today's presentation is going to be on blue roof cascade systems, which I'll talk about in the next few slides. So you might be thinking, who's EPG? Well, we're a very small company of around 10 employees, so it's absolutely tiny, but we are leading in terms of innovation, and we've been around for about 20 years. And as a company, we like to get involved in contaminated land remediation, gas protection, sustainable water management, flood risk, and even structural waterproofing. And we've also been involved and authored a number of technical documents in the field of SUDS, gas risk and contamination. Our main business objective really, I believe, sustainable design and mimicking nature as far as possible. Today I'm going to be talking about cascade designs, which broadly falls under the banner of sustainable drainage on the top left of the slide. So I'm going to pick up where Nicholas Wright and left off in his presentation and talk about where there's more than one blue roof on a project. So you might be asking, what's a cascade? So a cascade is where you have one water storage device that feeds or discharges into another water storage device in its simplest form. This can be a blue roof at one level discharging into another roof at another level, or it could be a blue roof discharging into a blue roof at podium level, or even a blue roof discharging into a below ground attenuation tank. So the aim of a cascade system in essence is to restrict the flow rate as low as possible and utilise all the storage mediums available prior to discharging into a soakaway or into a watercourse or a sewer. So I've constructed this example that you can see on screen, and I've tried to show a cascade link by using these green arrows. But let's imagine on this example that all the roofs on the project contain a blue roof attenuation system, and that could be a geocellular system as was on Angel Gardens, or it could be a cup-sated system, or it could even be a gravel attenuation system underneath the landscaping. I'll start from the top from this example, which is generally where I start when I model a system. So the top of the system is level 21, as you can see on the screen. And in this example, I've split the roof into two sections. So one part cascades to the west and one part cascades to the south, which you can see with the arrows. And this could be due to level differences or something like that. So to the west, level 21 discharges to level 19. And at level 19, the runoff from level 21 can either be further attenuated or stored to decrease that discharge rate, or to top up a passive irrigation system, which Nick's already touched on as well. So I should note that a passive irrigation system is frequently commonplace now, and is increasingly requested by landscape architects because it decreases or lessens the requirement to use potable water as the source of irrigation. So as you can see with this example here, we're discharging from one roof to another all the way down to roof 7. Where the roof then cascades to the podium level. And the beauty, as I see it as a cascade system, is that you can have a roof, let's say a large roof with a small plan area or a small blue roof build-up in the system. You could have a potentially high flow rate from that roof and an unavailability of storage within it. But with a cascade, that roof can outfall to another roof with potentially greater plan area or deeper storage depth. which allows the pass-forward flow rate to be massively reduced. We can do that by specifying a smaller flow control. You can keep doing this as you go down the system. So in essence, a cascade system allows you to balance the storage and the flow rate and the passive irrigation capacity just to fully optimize the system. So in the example, you can see that the cascade can discharge to a podium, or it can discharge directly to a below ground attenuation tank network. It can even discharge into a car park attenuation system for further storage or to reuse or reharvest the water that you've captured, which has already been touched on. It should also, and just in case you're interested in the modelling side of the cascade, EPG model with a variety of different programs, but most frequently we use micro drainage or XP drainage, which I think is now being replaced by something called MD subs. But if you'd like to ask any questions on the modelling or the design of a cascade system, please feel free to contact me after this webinar. I'll happily discuss. So I think I've touched on a couple of these already, but I've created the bullet points on screen just to show the main advantages and disadvantages. So with a cascade system, I mean, one of the main benefits that I can see is that on each level, there's going to be a massive reduction of pipework going through the building, because the pipework serving the overflows and the flow controls are going to pass from one route to the next. So in essence, you're not going to have multiple pipes going through the risers. And also with the cascade system, I think Nick's already touched on the smart technology, but with a single roof or even a cascade arrangement, you can link into the building management system. When you couple that with a sensor, you can provide telemetry to tell you if there's a problem, such as a blockage occurring. And with a really smart system, you can go even further than that. And I'll discuss smart systems soon. Well, with a cascade, we often see massive reductions in total flow rate as the system as a whole can be balanced and tweaked, as already explained. And all of the available storage depth can be activated, and you can play with that to make sure it is. So roofs with small plan areas, as I've explained, can gain the required storage on lower levels. Greenfield flow rates are also usually achievable, and basically that's the main principle of source control is a cascade system where we're going from roof to roof and we're using all the inherent area that's available to us. And in Manchester and other big cities, really, due to population increase and obviously building footprint increase, there's a lack of storage or siting of storage on a site with a minimal footprint. So a cascade design allows all roofs to be active and to store over all the inherent footprints. And of course, it's environmentally friendly as well. And well, the main disadvantage that I can see here is probably getting involved at a late stage of the development. So getting involved in a late stage usually means it's difficult to thread one pipe through to another roof, and that's due to sort of riser locations that are typically located away from the next roof that you're trying to connect into, or you've got a slim build-up in the landscaping depth which already has been decided, or threshold levels that have already been set. So I think the take-home point really is that early engagement's really the key to success when looking at a cascade system. And trying to retrofit a blue roof at REBA stage 3 or 4, I think, is quite problematic, and especially with a cascade system, it's often problematic. So I'd like to mention the picture on the left-hand side, the large picture. That's Polypipe's roof in Aylesford, and it's a really interesting smart roof. It's got its own weather station, as Nick's described, and it also collects its own data. And I highly recommend checking out their website for a few further details on the system. It's really interesting. But smart technology as a whole allows a cascade system to be used for both passive irrigation and for storage within the same volume build-up. So traditionally, with an orifice plate limiting the flow rate, the passive irrigation volume used to have to be separate from the attenuation volume, because the attenuation volume needs to half empty within a 24-hour period. So it's ready to deal with the next storm. So in essence, you needed to get as much water off as possible. So you had to have two completely separate systems. But with a smart system, the system as a whole sort of monitors the weather and retains the water until the next storm, and it only discharges that water when it needs to as a new storm's incoming. So it does that with its own weather station and information being received by cloud technology. So with that in place, it allows for a near interrupted service of passive irrigation volume, and the water is only then discharged before another storm comes. So it just collect more and more water. I've got a case study here, and I actually picked Dialon, which I'm apologies, it's not actually in Manchester, but it's one of my favourite examples for a cascade system that's just got a number of different systems all acting as one. So this site was built up on all boundaries, and without a blue roof system, there was going to be a requirement for an absolutely massive below ground attenuation tank, and that would need to be pumped. So we added the blue roof system on all the roofs, and the roofs cascade down to the blue roof raft on the podium. And we've managed to restrict that to 10 litres a second for the 6,000 square metre site, and it discharges at 10 litres a second in the 100+ climate change storm event. And this massively reduced the below ground tank using the SUDS features in the cascade, which really helped the civil engineers on the scheme, because they had no idea where they were going to put this tank, you see. And on this site, actually, there's passive irrigation, there's rainwater recovery and reuse that we've enabled within the spare capacity that's inherent within the blue roof system. And the captured water was reused as a conventional top-up irrigation system. And the landscape architect was really happy with that, because it allowed the bedding in period for the planting, and also it allows for sustained long droughts. You can then reuse and use as a regular top-up irrigation system. So using the cascade system here allowed for the site to be limited at the flow rate stipulated by the local authority, whilst also optimising the system so that the passive irrigation and water reuse could be enabled. And as you can see with the pictures, the bottom left is the podium that's being constructed, and you can see the superstructure rising up as well. And the middle and left pictures are the podium after it was completed. And if you can imagine, there's a whole blue roof raft under the whole of the podium there that's allowing passive irrigation as well as storage. And you can see the tiered roofs, tiered cascading roofs. And that draws me to the end of my presentation. But I must say I'm definitely looking forward to Francis speaking from TEP, as he's going to discuss a project that we've just been involved with called Northern Routes, and I'll leave him to explain that. But thank you very much for listening, and stay safe. And if you've got any questions, please give me a shout, and I'll happily respond to you. So.